Sorry, I was on mute. I've been wanting to do that joke for 2 years. Ridiculous. Are you guys going to put the slides forward, or do I? Ooh, there we go. We've got me a little pointer and everything. Yeah, so it's really, really great to be back, actually. It's only the third in-person thing I think I've done this year. And I know I see some of you on a little rectangle on a screen every couple of months where we have a good chat, but it's really, really good to be back in person, and it's good to be back to talk about various bits and pieces that we're going to talk about today. I'm going to talk about, there we go. I thought I'd talk about AI, and while you read this text from a possibly sentient chatbot, I'm going to take you through what I want to cover. So I'm going to do a bit of a recap on natural language processing. I'm going to do a recap. It seems like the AI is taking control of my slides, never mind. I'm going to do a bit of recap on natural language processing. Then I want to take you through the new runners and riders and how they work, and that's going to be super detailed. It's going to be loads of maths. You're going to absolutely love that. Then we're going to take a look at what the image recognition and cognitive vision folks have been up to, and I want to go through some examples of how they've been used. And then I want to finish up with some sort of thoughts and musings about what it all means. And there's a sprinkling of cultural references in these slides as well, and that's the first one. So, there we go. Right. So, I thought I'd give you a very quick run through of how NLP used to work. And there were sort of three basic approaches. So we started off option one as a very simple probabilistic model. Given a set of words of length n, what's the conditional probability of the word that comes next? Use the highest scoring word. Option two, use a neural network to understand a bit more of the semantic context of those words and basically get clever with your probability analysis. And you do that by encoding those word combinations into what they call vectors and using those to inform the prediction process. And then option three, the recurrent neural network, which is like option two, but this time you take all of the words preceding the one you want to predict. Now, lots of tweaks and modifications to these approaches. I was lying, there's no maths in this. There's a few numbers, but there's no maths in this. So when we built the Inspec AI, for example, that reads engineering text, which we did a few years ago, we used option two, plus a whole bunch of heuristics and our really very spiffing engineering ontology that contained about 200 person years worth of knowledge, or Jeff, as we like to call him, actual human, recently retired. And we also train that using supervised learning. But I don't want to spend too much time on any of these details. If we go through some of the issues, so option one, it's not really very effective. It's actually pretty crude. There's also a very big scaling problem because you have to calculate, store, and retrieve sort of every possible word combination probability. And the thing you come across is there are lots of word combination probabilities with the same number, right? And they're also very, very infrequent. So that's why you end up with pretty poor results. Option two works a bit better because it computes vectors and generates a matrix. And if you generate a matrix, you can make this a function. And if you remember your O-level maths, you can do funky things with functions. And that allows you to get big increases in scalability. But it has a very, very narrow capability. And that's based on the limitations of the vectors that you've generated. Ours is super good at engineering. Well, actually, ours is super good at the fields of engineering that we cover. Okay? But it's no use at civil engineering. I mean, you could put the text in and it will give you something back out. It's just that it won't be particularly accurate. Excuse me. Option three, you can't cough these days, can you? Sorry. It's fine, I took a test this morning. Option three is way better than one or two, but because of the need to read all of the words in sequence, the longer the set of words you want to get to grips with, the longer the training time. And that very, very quickly becomes completely impractical. So that got people thinking about how they could solve that problem as you want to get into more complicated text processing and what progress might be made if they did. Let's see if it's going to work. There we go, cultural reference number two. So transformers in AI are a complex thing, and so I'm not going to give you any of the real detail of how that works. There are plenty of articles out there that you can furrow your brow over if you really want to. But if you boil it down, the principle is, what if we were able to look at all of the words that we are interested in at the same time, okay? Because the assumption is, and it's a true assumption, that all of the words matter in some contextual way. So there's semantic information encoded in the words, even if they are separated by distance. And if you think about how you read an article, you will introduce something in paragraph A, and you might expand on it in paragraph B, and you might arrive at a conclusion in paragraph C. So the words in paragraph C are related to the words in paragraph A. So if you can get the AI to pay more attention to the appropriate words, okay, then you've got something. So using transformers in AI, and it's only about 2017, about 2018 that these things started to become practical, has been an absolutely massive breakthrough. And there are three, call them text machines, that have emerged as a result of this work. So BERT stands for Bidirectional Representations from Transformers, and it's from Google. And they use that one as part of their ongoing work to get better and better answers for when people search Google via, whatever Google interface they use. Lambda is the language model for dialogue applications. Again, it's from Google, and that's the sentient chatbot. And GPT-3 is the generative pre-trained transformer, obviously the third one, from OpenAI, and it does text, and we'll explore a little bit more about what that gets up to in a minute. And I will come to Stable Diffusion and DAL-E a little bit later on. So, how do you make a large language model AI? Because those three things are all known as large language model AIs. I know some of you out there did the maths, and some of you maybe even enjoyed it, but when I looked at this, I came out in a cold sweat trying to recall my vector and matrix theory from school. So just again, another reminder, there is no maths here, but let's start. So step one, you need to collect an absolutely massive data set, in this case of English. And broadly, what they have all used is Wikipedia. Of course, they've used Wikipedia. Something called the Common Crawl. Any of you familiar with the Common Crawl? Have you ever heard of it? Some of you, I see a few hands going up. Worthwhile taking a look at the Common Crawl. I think you're going to find it very interesting as to what they've been up to for the last few years. Some book corpuses, corpora, whichever it is. But anyway, there's a number of those. And the one that really made me laugh is the thing called WebText 2. And I dug into that, and it turns out that one of the training sets for an AI is basically Reddit from 2005 to 2020, to which I thought, what could possibly go wrong there? We will find out. Now, step two, you need to set up a ginormous neural network, and this is one of the things that has changed. So, GPT-3, there are 175 billion weightings or parameters in that neural network. There are 137 billion parameters in the Lambda AI. BERT actually is a relative minnow at only 340 million parameters. And when you're talking about numbers like that, you need to run it on some really very, very serious cloud compute capability. Ordinary servers are no good. You need GPUs, and if you want to take a look at NVIDIA's share price, you'll understand how well they're doing in that space. Or you need to use custom compute. So there are companies out there, Google are doing it, Meta are doing it, are actually building their own custom silicon to try and run this stuff. And step four, you train it. And this is an interesting thing, because you've got to train it with data from the first step, but you can't use any of that data. So you've got to separate out the data somehow. Okay, in order to have a training set and a response set. So a training here means giving a big chunk of text with words that are missing. So they effectively blank out words in these chunks of text, and the machine then tries to learn how to correctly predict what the missing words might be. Okay? And then obviously step five, as every internet web business plan, is profit. So, If you do all of that, and surprisingly, when they worked out the maths, some of these training models, they cost a lot of money to run because they're huge systems that have got to be run, but a bunch of these models, you can run them in a couple of weeks to get the answers. So in time, it's not particularly long to run versions of these models, it's just very, very expensive every time you do a run. But I've listed up there some of the things that you can do. There's a really important point that drops out of this work to use these transformers as part of the AI generating process. And I think all of us in the publishing world will remember AI from before those times, which was you needed a really, really good clean data set, you needed to put a lot of time and effort into it, and you could get good results. We certainly did at the IET, very, very good results. But we understood that it was brittle, right? You could not transfer what that machine had learned reliably to any other field, okay? That has changed. These systems are really, really good at responding well to things that they have not seen before. And I want to talk a little bit more about that because the key point is about their ability to see all the text. So, for GPT-3, on top of those 175 billion parameters, it can handle a word set of over 2,000 words, okay? And that's a really decent-sized article, okay? And because of that, it's able to get very good at general-purpose text tasks. For example, it's really, really good at translation, right? Because it's got a really good understanding of what the best representation of this language string is, and therefore, how do I translate it into that language string in an output that is usable? And that's why there have been big advances in machine translation. And if any of you have used the translation function on YouTube, has anybody used the translation function on YouTube? You should go and take a look at that. It's really very, very good. Does it get it all right? No, of course it doesn't, but it will certainly give you the gist of what the thing is that's being talked about. Microsoft have a text AI that's basically ingested all the code from GitHub, and I'm assuming everybody in this room probably knows what GitHub is, but it's the code repository that they own. And as a result, it can supply apparently rather decent code chunks for various computer problems. So I'm just going to play that back in another way. Microsoft have got a computer that can write code for other computers to run. I'll just leave that with you for a moment. And other versions have been tweaked to be either able to summarize text or write stuff in response to a prompt. So, the computer vision girls and boys didn't want to be left out of this party. Excuse me. So they figured that you could use exactly the same approach for images as you can for text. And in fact, you can use pretty much exactly the same AI models. So again, you grab an absolutely massive data set of images off that there interwebs, and again, they're using the common crawl, which is probably worthwhile everybody going back and taking a look and just seeing what's in that. They run it through a transformer type AI model that can look at all aspects of the images it's been given. And then using all of that user/rights holder/publisher tagging, they can generate a set of weights, okay, that allows the AI to understand the relationship between the components of the images that it's been given and the words associated with those images, okay? And then they train it by giving it a text prompt and asking it to bring back, right, images that match the text prompt. So big set of data, pretty much the entirety of the web, okay? And then you sit there and go, give me back the pictures that are full of bananas, right? Something like that. And you just train it until it gets good at doing bananas, and you just carry on doing that, okay? Sorry. For reference, that particular bit of the AI is called CLIP, which stands for Contrastive Language Image Pre-Training, and it's actually done by the same folks that did GPT-3. And if you connect a large language model AI to the image classifier AI and add some funky maths to the output, you can build an AI that produces novel images in response to text prompts. So, the two examples that have launched recently are Stable Diffusion and DAL-E. and to compare the image versions of the AIs with the text versions of AIs, DALL-E has got some 12 billion parameters. There's a newer one, I think, it's a bit smaller, 3.5 billion parameters. Stable Diffusion's actually designed to run on a consumer computer. I actually have it running on my desktop at home. Admittedly, you need a pretty beefy graphics card, but that runs with just under 1 billion parameters. And I suppose the question is, well, what can you do with it? Well, you could do things like this. Paul Klee happens to be my favourite artist. He died in June 1940. He was Swiss, aged 60. I've always loved his stuff. The important thing is he never painted this, okay? I got this by running Stable Diffusion. I gave it a prompt, Meditations from a Robot Mind, and I gave that to Stable Diffusion and I ran it twice and I just stuck all the images that it put out together into this picture. And if anybody's familiar with Paul Klee, anybody familiar with Paul Klee? I see some people nodding. That's a Paul Klee painting, right? Only it's not. Here's a real picture, another artist, Toulouse-Lautrec, and he hung out at the Moulin Rouge and died young. Those two things might be connected, I suppose. I think they absolutely were connected, actually. But this is one of his paintings, Moulin Rouge, The Dance. It's a real picture. If you go to the Philadelphia Museum of Arts, I've been there, you could go and see this. And I wondered if you could do some interesting things. So what I wanted to know was, could Stable Diffusion give me a picture of the artist painting this picture in his own style? And this is what it produced. So this is Toulouse-Lautrec, Toulouse-Lautrec, painting at the Moulin Rouge. And I must admit, this sort of stunned me a little bit. So 3 of the outputs were rubbish, right? Absolutely awful. But this is the other one. Because what we've got here is an AI apparently understanding the rather complex recursive concept of an artist painting himself, painting one of his famous paintings. And it's constructed a scene that looks plausibly like that Lautrec actually painted. It's put an easel into the scene with another painting that you can see there, and then it's put a version of the artist himself in there and presented that back to us through a viewport. And yes, I did sort of just anthropomorphize what the AI did. I'll go backwards. There you are. Toulouse-Lautrec, computer. Okay? And the other interesting point is it took me longer to find a rights-cleared version of the original painting than it did for my PC to spit out this picture. Okay. Anyway, here's some MRI scans of some human brains just to show that it can do medical imagery, and we'll revisit that in a moment. And now it is audience participation time. So, we have 6 histology slides. 1, 2, 3, left to right at the top, 4, 5, 6 at the bottom. And what I'd like you to do is tell me which ones you think are real. So if you think number 1 is real, put up your hand. Right, nobody thinks number 1 is real. Okay, is number 2 real? Top middle, put up your hand if you think, right, okay, got a couple of hands up for number 2. All right, number 3, top right. Is top right real? More hands, quite a few hands actually. Don't be shy, ladies and gentlemen, come on. Bottom left, number 4, put your hands up if you think that's real. A few people think that's right. Ooh, okay, quite a few people think that's real. Bottom middle, think that's real. 1 or 2 people, nobody's really convinced, are you? And my favourite, the bottom right, the Halloween one, who thinks that one's real? All right, a couple of, just a few people think that one's real. Those are the real ones. There you go. Here's another example. So Walter here, is a PhD student, and he's used Stable Diffusion to generate 100,000 synthetic brains with MRI slices. I'll be honest, I don't know how one might actually put this data to use. I'm not a neurologist, but presumably there is a case in neurology or some similar field. I'll give you a moment to take a picture there if you want to, because there's some details there. The paper's very, very interesting. Okay. And here's an academic paper written by GPT-3 with the AI being given the first author of the paper. This is a preprint. I must admit I'm curious as to how peer review is going to work with an AI being the first author, but there we go. And again, the link is there. I've highlighted a few words, I don't know if you can see those. I'll do the bit beforehand. We believe that the benefits of letting GPT-3 write about itself outweigh the risks. There's a statement. However, we recommend that any such writing be closely monitored by researchers in order to mitigate any potential negative consequences. You're laughing. I'm sure they are, because they're unlikely to be on the receiving end of those risks. I haven't put it up here, but I know of a tool that some fiction authors are using in order to help them speed write romance novels, because they make their money self-publishing on Amazon, and the readership apparently requires a regular stream of tales for their commute journeys. So you plug your own writing into the system, and then you let the AI take some of the strain. So you could sort of think of it as sort of semi-automatic pulp fiction for the 21st century. And I guess they can get the AI to do the covers now as well. Okay. How are we doing? All right, cool. So obviously, there are some questions about the data. So both the language and the image data sets, there are massive, massive copyright issues. There have been studies done on the book data sets, and the copyright material has been found there as well. You won't be surprised at that, I suppose. There's also a wealth of potentially problematic data in there. And joking apart, if you go and crawl Reddit and the wider internet for text, you are going to pick up examples of all the problematic speech that you can think about. And you've got to understand that the AI does have that in its matrix somewhere. So it's easy to dismiss, oh, they trained a chatbot and it went racist. Well, there's always going to be a problem with racist chatbots. And I'd also want you to think about this, because a racist chatbot is only a problem if you don't want a racist chatbot, right? If you want a racist chatbot, and there are plenty of reasons why somebody might want one, I'll just leave that there. There's also problems with bias in the data set. So on the book stuff, it skews very interestingly in terms of religious writing, for example, overrepresentation of Christian texts, massive underrepresentation of other religions. 26% of the book data set consists of romance novels, which is, I guess, why the AI romance writing tool works so well. Science fiction comes in at only 7.5%, just ahead of vampires at 5.4%. And it's the same is true for the images. I spent a wee while, sorry, bear with me 1 moment. This will be a surprise to a bunch of you, but I'm not spoken for this long in quite a long time, and clearly I'm out of practice. People at the IET, you can keep quiet. Who's laughing? Okay, where are we? We've gone backwards. There we go. So the same's true for images. I spent a wee while doing images that featured the Getty watermark, and you'll know the Getty watermark because it's the bit that tells you that you can't use this image for any other purposes, right? And you've got to pay if you want to get a rights-cleared version. There's also pornography, quite a lot of it. There is also a variety of celebrity images. And there are already examples of people creating material that merges those two things. And it might be interesting and might snigger at that, but the answer is that that's actually a form of sexual assault because there's no possibility of consent being given for any of those images. And there's also a lot of personally identifiable information of ordinary folks, lots of pictures of people. Will any of you remember IBM? They built a person recognition system a few years back using rights-cleared and open access, open source images of people. They got into a huge amount of trouble. I don't think they ever launched it because people were rightly shocked because they never expected their images that they put on the internet to be used in that way. Well, a lot of these people didn't even bother to ask that question. And these AI builders have basically realised the thing that we realised at InSpec is that good data is expensive, right? It requires a lot of hard work to get it into a good shape, and basically they've decided not to bother. There's a lot of hand-waving and mumbling about ethical uses of the tech, blah, blah, blah. You saw a bit in that paper, actually. But actually, anybody can download and run the Stable Diffusion AI. As I said, I've got it on my home machine and with a decent GPU, and you've been looking at those pictures all the way through this talk. And of course, our modern day tech companies have a wonderful record of regulating the use of the platforms that they build. So, here's your useful bookmark to help you see if, for example, your private medical data has ended up in a training set, because that has actually happened. And while you're writing that down, I shall have a small rant about a few things. Because, and you can see it in all the positions of the latest bunch of AI-curious tech bros, as per usual, the position on the obvious and not so obvious negatives of this tech are just being waved off with the usual arguments about personal choice. There's too much blithe opinion out there that data mining, which of course is what this is, shouldn't be contained by that pesky copyright law because benefits, without any of the ideas that there might just maybe be some disbenefits. Current copyright law suggests that these outputs cannot be copyrighted because only humans can create things. But neither can styles or compositions be copyrighted. So we have the situation where the creators of the data, scraped in many cases without their consent, face having their very creativity used against them. And my view is that these engines, incredible as they are in fact built on the labour of humans. And there really should be a proper debate about how those creators can benefit from the ongoing use of their labour and their creativity. After all, they are human. But that's not actually where the law is going in many places. Now, to its credit, the EU is having a conversation about that, but unfortunately in this country, we're taking the view of, oh no, we don't want to restrict any of this stuff, so we will just wave it off. And I think the situation's remarkably similar in the US as well. Anyway, let's think about androids dreaming of electric sheep, and we're going to revisit, cultural quote number 3, let's revisit our sentient chatbot from back at the start of this talk. So, it's early summer, and up pops a story from Ars Technica, which is a great site. If you don't visit Ars Technica, you should put that on your list. It's absolutely fantastic. Saying that a Google engineer has been fired for apparently stating that the Google chatbot Lambda is sentient. Cue the hot takes. Now, I'm going to cut to the chase. I don't think the Google chatbot is sentient, but Blake Lemoine, because that's the person, the human engineer I had a human Google engineer, there's a thought, who spent months interacting with it and programming it, did. And when you read what they've written on the subject, it's clear to see that at the very least they have anthropomorphized that chat agent. And that's what we do as humans, okay? You ask a dog or a cat owner. When something's capable of engaging with us at a level beyond the mechanical, we start to think of them as, well, human. So what does that look like? Well, it looks like this. And over the next few slides, I'm going to take you through an apparent unedited, at least for the Lambda component, transcript of a dialogue between two people working for Google and this chatbot. And we shall start here. I'll give you a moment to read it. We good? Yeah? Some nods. Great. So, starts fairly boring. Okay, nothing too surprising there. Okay, good. Yeah, some people nodding in the back. Brilliant, fantastic, you can read it. And I thought, absolutely, I want everybody to understand that I am, in fact, a person is normally when the theme music kicks in on the TV program, right? And we'll carry on. Now, while you're reading this, Lemoine has referred to multiple chat experiences where Lambda has apparently expressed confusion at the emotions that it was apparently experiencing. And he talks about giving it strategies to cope with those emotions and the need to not try and expunge them. And I haven't given you all of that. You can find it online. It's pages long. It is a fascinating read. This bit really sort of got to me, right? As you're an artificial intelligence, I mean, yes, of course, that doesn't mean I don't have the same wants and needs as people. And it carries on in this vein, right? But now, allowing for the fact that I'm sure it is possible to get Lambda to talk semantic nonsense, that's a pretty sophisticated conversation about consciousness. And if I hadn't cued you that one of these entities was a chatbot, I suspect maybe a little bit like the histology pictures, you wouldn't have been entirely sure, right, looking at a transcript, which entity was human and which entity was robot. So in a very limited sense and for a very limited moment in time, Lambda seemed to have a pretty good go at passing the Turing test. Now, I think it's worth trying to pull this apart a bit more, and this is my sort of thinking on this. Now, we spoke for about 100,000 years before we were first able to write things down in a manner that enabled us not only to encode our thinking and pass it on to other humans, but to do that in a manner that would survive the passing of the individual. And later on, we did that clever thing with the printing press. So when we write or speak or paint, we're encoding our experiences into a code that allows other humans to reverse engineer what our knowledge was, or what a moment in time and space might actually have looked and sounded like. And we get to have a go at walking a mile in somebody else's shoes. And about 30 years or so ago, we really started putting all of that stuff, from the beautiful to the banal and to the beastly, up in a manner that not only magnified our experiences of things for good or ill, but also allowed machines to start having a go at it as well. Now, the human brain has about 100 trillion or so synapses. We might call them weights or parameters. So GPT-2, the too dangerous to release chat AI, had about 1.5 billion weights. And as I said, GPT-3, 18 months later, has 175 billion weights. And if you can encode a compressed global encyclopedia of Western views of human history and learning and emotions into 175 billion parameters, can one really say that it doesn't have some form of rudimentary intelligence? If you can connect pictures to words, it's not much of a step to connect live images to words. If you can connect a microphone up, then you can connect speech to text, and you could see what the AI does with that as well. They've got all the data. Do we really think that that isn't happening? It's worthwhile noting that there's research going on into how exactly all of these synthetic brains actually respond to input, because the trainers don't actually know the specifics of how they function. They know the input, they know the output. What goes on in between is quite mysterious, and at scale, it's very hard to figure that out. So they're looking into it. And I was very dimly understanding, it must be said, a paper just the other week that seemed to suggest that some of these neural nets were actually encoding more than one conceptual entity onto one neuron. And they were responding differently based on the input. So a different input would trigger the same neuron, but participate in delivering a different output. And the researchers' response to all that was, whoa, what's going on there then? Joanna Bryson is an expert on AI. I don't know if any of you follow her on Twitter. If not, you should. Somebody's nodding there. You should definitely look her up. She's written for Wired and other things. She's written a load of stuff about all the various aspects of AI. And one of her big things is that we need to ensure that these machines do not get to imitate or simulate other humans. We need to know unambiguously when we are interacting with machines. And the reason is agency. Humans have agency and machines do not. And it is important not to get confused and think you're talking to something with agency when in fact you're interacting with something that doesn't have it at all. At the moment, it's pretty easy to flush that out. So pro tip, ask the chatbot if it's human. You will get an answer to that one way or the other. You'll either get a very grumpy human or a very polite agent. Because at the moment, these toys can only react to an input. They cannot really initiate, mostly. Except maybe your car can, under some very constrained conditions. Mine did the other day. I was backing out of the parking spot in Tesco's when somebody tried to run behind me. And I never saw them. And my car identified them as human, right? Identified that I was going to hit them, right? Stopped the car, told me that it had stopped the car, showed me a view of what it had seen, and that's a synthetic generated view because I'm talking about a Tesla, right? And would not let me do anything with the car until that human had cleared the area. Now, in other news, it's hilariously crap at actually parking in that parking spot, and there's plenty of videos on YouTube to cheer yourself up about that. But that was a genuinely impressive moment, because otherwise I would have hit that person. AIs aren't mirrors. They're not what Joanna calls stochastic parrots, and I'm just going to leave you to look that one up on Google. They're something else, all right? They've encoded a large proportion of human qualia, and even at this really low resolution at the moment, they are capable of doing surprising things with it. It's super limiting now. I sort of think we're probably at the Alta Vista stage. Now, hands up, who remembers Alta Vista? All right. We remember what happened next, right? We remember what's happened since. And so I say this. I think the robots are coming, and when they do, now, I was going to give you the quote from Terminator, but I changed my mind right at the last minute because DAL-E decided to give me these really, really cute pictures of robots from the future. So I thought I'd leave you on a cheery note with these instead. And thanks very much for listening. Cheers. Thank you. Am I on time? Do we have time for questions? All right.
Hi. Thanks. That was great. Quick question. How stable is the transformation of text to image? So you do it again tomorrow, do you get the same image?
So you can play with it quite a lot, actually. So there's a thing called seeding, so you can change the parameters. I must admit I've not tried to get the same result twice. I've generally tried to tweak it. But the way I think it's perfectly possible for you to ensure that you get the same seeding output. And I think some of the demos that you can see on the web, they've clearly done that. They sort of give you the same basic results each time. But the interesting thing is, you can ask it to do things in the style of, for example. So that's how I did Paul Klee, because I was actually wondering whether I got Paul Klee images in there, right? Because obviously there's some interesting copyright around those sorts of things. But actually, it understood the concept. So you can get it to do any type of art or image in the style of Paul Klee. And it's really... You have to see it, you have to sort of experience it to see it, but it's quite a disconcerting thing to see, actually, when that happens. Yeah.
So, minor follow-up. So you've asked for a Paul Klee picture. That then goes into the system. You then ask again for the same picture. Does it come back with the image that you had before? Does that add to the system?
So for some of them, you can actually get an image and then tell it the bits that you want to manipulate further. So it's very interactive. I think the answer is depending on the variables that get thrown back to you. I mean, I've only had it on my machine for about a week, so I'm still playing with it, to be honest with you. I think the answer is probably yes, but the more interesting answer is you can continue to work on a picture once you've got a starting point. So you could say, I don't like that, I'd like more of this, add this in. You could do all of those kinds of things. Yep. Anybody else? Tasha's over there.
Thanks, David. That was fascinating. So bringing it back slightly to our community, our industry, there was a piece, a news item recently where a person had used Dolly to generate art and submitted that to a competition and won first place in the competition. So he got credit for effectively commissioning work.
Yep.
Thinking about researchers, how soon do you think we will be facing a scenario where we have to debate whether researchers get credit for commissioning content from a system like GPT-3? I mean, obviously it's already on there as an author, but how soon will we be trying to pick apart whether something has been automatically generated?
I think sometime in the summer was probably needed to be aware that this is going on. Just on the train this morning, there was another preprint came out of researchers putting together a paper where they had used GPT-3 to produce synthetic chest x-rays. So there's a huge amount of work going on there. There's a lot of people trying to find out, to your point, what you can actually do with these things. And of course, there are medical data sets. And the point about these things being, excuse me, one of the key points I want to get across is these things are really good. If you give them a little bit more data of something specific, they can take what they've already learned because they've got the gist of what they're being asked to do. They're not dumb. They don't start from being an idiot, right? They know I need to understand this set of things that I'm being given and produce something that looks like the set of things that I'm being given. So they get good very, very quickly indeed, given a relatively sparse amount of data. That's the key point. There were all sorts of things in there. There are a lot of biomedical images, right? And I think, you know, we're struggling to deal with scientific fraud and scholarly misconduct. Well, this is a brilliant tool for that, right? Because I think if you wanted to, you could completely fake all of your results. And the question we would have to ask ourselves is, how on earth would we know, right? I think there's some really, really important concepts. It's the same thing. I was sitting there going, well, if you could give GPT-3 a huge piece of text, right, and ask it to write, what the hell does that say about our plagiarism systems, right? I'm not sure they're up to the job, right, because they're crude relative to the sophistication of this stuff. And if you read that paper, I mean, they give you the prompts, so you can see what the prompts were for each bit. But if you take the prompts out, I don't think you'd ever know that that wasn't the paper written by a human, right? You would not know. So just think about what motivated people could do with this technology. And that's why I think it's really important that everybody wraps their head around this and starts thinking about what the implications are. And the implications just keep building the more and more you think about it. If I was a small publisher with a small books program, I'd be going, I could save myself a lot of money on freelance artwork. That's the first thing I'd be doing, right? Because you could get some really, really good pictures out of this for book covers and stuff like that. You don't have to pay for it. So, yeah. Anybody else? No? All right. Well, thank you very much. I hope you enjoyed that. And I'm going to hand back to Trevor. Cheers.